Hey guys, welcome back to my channel called How To. Today we'll cover our lab 5 with DMVPN, which would be dynamic mapping with Eigrp with phase 1. Okay, so we have covered 4 labs so far, and I think we have got some clarity about phase 1 and phase 2 using static and dynamic mapping. Now from this lab, we will be using our routing protocol to advertise our loopback interfaces. Okay, so everything would be same the way we used to configure our phase 1 and phase 2. Those concept will be same. The only difference would be now onwards we will be advertising our loopback interfaces that we haven't touched so far. Okay, so the IP parameters have been configured already. That's something I think it have been configured. So IP interface brief. So the IP address would be, yes, these are the public IP address and that we were treating on our lab outside facing interfaces, and these are our loopback interfaces. Okay, let me check real quick. The other router, these are up on the spokes. So interface brief. Okay, the IP address and the loopback address has been verified, and even spoke to. Fine. So DMVPN, nothing has been configured. So running config for interface tunnel 10. Anything? No. INC tunnel. Nothing. Okay. Only the IP address have been configured so far, and definitely our what have been configured. Okay. Let's check the reachability to from spoke to hub just to make sure we are having public IP address reachability. Dot one, it is our hub 1 public IP from spoke 2, and from spoke 1 let's check the reachability 110.110.1. Okay, so from spoke from both the spokes we are able to reach out to the hub outside interfaces. Now let's configure the DMVPN first using our phase 1 the phase 1 dynamic mapping for the DMVPN. At the end we will be using Eigrp. Okay, so let's proceed from the hub first. Okay, config D. I'll just open this side by side, something like this. Okay, so let's configure the tunnel first. Interface tunnel 10 IP address would be 193.168.100.1, having mask of /24. No set exit. Interface tunnel 10. Tunnel source should be our gig 0/0. Tunnel mode would be GRE multipoint. Why so? Reason being we are using our dynamic mapping, right? Tunnel mode GRE multipoint. IP nhrp network ID would be 10. Let's keep it 10. I think that's what we have been keeping out for other videos as well. And tunnel source, tunnel destination, tunnel mode. I think that's all for the hub. So running config for interface tunnel 10. So the IP address has been configured, network ID have been configured, tunnel source have been configured, and the tunnel mode have been configured. Okay, so let's form DMVPN first, and then we'll come back to Eigrp and we'll try to advertise our loopbacks using Eigrp on the hub and the spokes. First, let's configure DMVPN. Let's go to spoke 1 real quick. Config D interface tunnel 10 193.168.100.250. Tunnel source would be tunnel source gig 0/0. Tunnel destination would be our IP address of the hub. Tunnel destination would be 1110.1. Mhm. Am I right or wrong? I just forgot what should be tunnel. Tunnel destination would be the public IP address or the tunnel IP address. Tunnel destination would be okay. Tunnel destination, I suspect. Okay, I am suspecting tunnel destination would be this. Let's check out. Okay, I'm just confused right now. Okay, so what else we have been done? IP address has been configured. The tunnel source have been configured. The tunnel destination has been configured. Tunnel source. I think the tunnel destination would be no IP. Tunnel destination would be tunnel destination would be public IP address. That's what I feel. So tunnel destination would be the public IP address. Now, what else is pending? IP nhrp network ID should be 10. IP nhrp nhs. So what would be our next hop server, where our spoke will be registering themselves with the hub. So the next hop server IP would be tunnel IP address of the hub. Okay. So how this tunnel IP can be reachable? IP nhrp map 193.168.100.1. This can be reachable. This tunnel IP, this next hop server IP is reachable using public IP address, that is of this, right? So I think we have done these labs prior as well. So IP nhrp map. So for reaching out this our next hop server IP, what would be the public IP? So this would be the public IP. Okay. So I think that's all for this. So running config for interface tunnel 10. Let's see. IP address has been configured. The nhrp mapping has been configured. Okay, I think the mapping is wrong. The IP address should be 100.1, but it's like 100.10. Okay. So config D interface tunnel 10. No IP nhrp map reaching out to next hop server or public IP address would be this one. Okay. Do so run interface tunnel 10. IP address has been configured. So the same mapping has been done. Network ID has been configured. Next hop server have been defined, and the tunnel source, the tunnel destination. So let's quickly see either we have formed DMVPN or not with the hub. So DMVPN. So DMVPN have been formed with the hub, and we have formed the attribute was static, and the uptime for this tunnel was 1 minute and 27 seconds. Okay, so let's quickly jump into router spoke 2 and do the same. Let's bring up our DMVPN tunnel first, then we'll proceed with our routing part. So the config T interface tunnel 10 IP address would be 193.168.100.3 with the mask of 24. Tunnel source would be gig 0/0. Tunnel destination would be our 110.110.110.1. That is our public IP address of the hub. So IP nhrp network ID would be our 10 that have been defined. It would be same. So IP nhrp NHS next hop server would be 193.168.100.1, the tunnel IP address of the hub. IP nhrp, how we can reach this tunnel IP of the hub. So IP nhrp map 193.168.100.1. For reaching out to this IP, the tunnel IP, the public IP address need to be defined, right? So that's how I memorize it. So that have been done. So let's quickly see the DMVPN part. So DMVPN So the tunnel is up now, right? So DMVPN detail, right? So IP nhrp nhs. So they have been done. Now we have formed our DMVPN, right? And let's quickly jump into a hub and verify. Spoke one. So DMVPN, we have two dynamically formed neighbors, right? So it's a dynamic mapping. That's the reason. Now let's see from spoke. Either do we do have an reachability from spoke two to spoke one, right? So in our DMVPN, DMVPN, we could only see our hub as a neighbor, right? We wouldn't see spoke as a neighbor. So let's quickly verify either we can reach out to spoke one or not. I'll try to ping 193.168.100.2. That is IP address, like an internal IP address of the spoke one, right? Not the public IP address. So if I'll ping, I was able to reach out, right? Now if I'll type so DMVPN, you'll see the now we have an entry for this. So IP route, what else? We do have a reachability for the spoke one. If I'll do trace route 193.168.100.2, it's taking a bit time, so let's wait. So the first hop was our hub, that is 100.1, right? And the second would be our spoke. So that's what our phase one is about, right? Like everything will be routed via hub. Everything, like if spoke wants to communicate with each other, the traffic will jump into hub and then to the spoke and back and forth, right? So these have been achieved. Now our main goal is to use our Eigrp protocol to advertise our loopback interfaces. So let's go to router 1, hub 1, and configure Eigrp. Router Eigrp 100, no auto summary, network 1.1.1.1, wildcard 0.0.0.255, network to 11.11.11.0, 0.0.0.255, and then exit and go to interface tunnel 10. And I'll come back later on and I'll show you what we can do in the hub part, but let's quickly do the same on spoke one as well. Config D, router Eigrp 100, no auto summary, network 2.2.2.0, 255, network 22.22.0, 255, and then exit. Similarly in our spoke 2, we'll do the same. Config D, router Eigrp 100, no auto summary, network. What are our loopback interfaces? It's 3 and 33, 3.3.3.0, 255, network 255. Okay. Now you would be wondering why our Eigrp is not up, right? So router, so IP route Eigrp. We haven't got any never ship up messages on the console. Neither are we haven't formed any Eigrp, right? So what might be the reason? Okay, so IP route Eigrp. So IP Eigrp never, nothing, right? So the reason being why we are not able to form the neighborship is, if you have seen, we have a rule in Eigrp called split horizon rule. So what does split horizon rule says? Router will not advertise back the learned routes that have been learned from the same interfaces. Meaning by our hub is learning these routes that will be advertised from spoke to the hub, right? And it won't be advertised those routes to the spoke. Meaning by any route learning from the same interfaces won't be advertised back to the other neighbor, right? That's our split horizon rule says. But here I think I missed something. We haven't formed a neighborship between. At least we need to get neighborship between hub and spoke, at least for one spoke. I think I missed something in the. Let's see. So running config for interface tunnel 10. So tunnel mode GRE multi-point. I think I haven't defined anything for the multicast traffic here on the hub. Okay. Config T. My bad. Config T. I interface tunnel 10 IP IP nhrp map multicast dynamic. So meaning by what does this command says? Any multicast traffic that would be coming to me, right? To me. So the dynamic mapping will be happen, right? So this EIGRP, if we are aware of EIGRP use multicast addresses to to form the neighborship, to give the updates, to advertise the routes. So this command is must here when we are using any routing protocol. Okay. So let's enter this command and let's verify either we'll get our neighborship or not. So IPE as a neighbor, it's gonna be a good district lab, I guess. So config the interface tunnel 10. I'll just do the set and no set just to make sure. Even on the spoke side, config the. Did I miss something on the spoke as well? So running config for interface tunnel 10. I think even in spoke interface tunnel 10 IP nhrp map multicast dynamic. No IP nhrp map multicast dynamic. No IP nhrp map multicast dynamic. I think IP nhrp map. We need to define the public IP address of the hub for the multicast traffic to send out. IP nhrp map for the multicast traffic. Just send this multicast traffic to hub. That is public IP address of the hub. I think this is the command I missed on the spoke. Exit interface tunnel config interface tunnel 10 shut no shut show IP IGRP neighbor. Okay, let's do the debug part. Not the debug, but what I'm missing here. Okay, I'll just go with the spoke one as well and try to do the same that have been missed. Config T interface tunnel 10 IP nhrp map multicast traffic, send this multicast traffic to 110.110.110.1. So IP nhrp NHS is right. Okay, so IP IGRP neighbor. Okay, they have been done. These two commands have been added to the spoke and to the hub as well, but no membership have been formed. Okay. Let's try to fix this. Let's see what I'm missing real quick. What I'm missing, I'm just checking real quick. Okay, never mind. I was doing something else. Okay, what I believe is the command that I was trying to use on the hub at the end. I think that I need to use here first. Let me check real quick. Interface tunnel 10. I am just using split horizon rule. Just to disable split horizon rule and to check either we will be having the neighborship. So interface tunnel 10. This is really important. So no IP split horizon rule for Eigrp 100. Okay. So let's see if we can form the neighborship. So IP Eigrp neighbor. So running config for Eigrp. Mm-mm-mm. Config the interface tunnel 10 set no shut. So IP Eigrp neighbor. Strange. Interface tunnel 10. What I'm missing? So IP interface brief. Okay, what are the tunnels? So IP so running config for interface loopback 0. Mhm. What I'm doing? So router. Mm, okay. Okay. I got to know what I'm missing here. Okay, my bad. What I'm missing here is I have advertised the loopback interfaces, right? But I haven't advertised the tunnel interfaces here. Okay, so that's the reason, we are not having the neighborship up. So let's quickly jump into route. Let's quickly jump into hub one first, and I just want to disable this. I just want to remove that EIGRP split horizon rule here, just to make sure you understand, what's the effect of it and the use of the command. So to show running config for interface tunnel 10, mm, you'll be using split horizon rule here. Config T split horizon is by default enabled, so IP split interface tunnel 10 IP split horizon for EIGRP 100 is enabled. Okay, so let's quickly config the router Eigrp 100, advertise our tunnel interface, that is 193.168.100.0.255. Network 193.168.100.0.255. Okay, similarly in spokes, config the router Eigrp 100, network 193.168.100.0.255. See, we have a never ship that is up right now. Okay, similarly on spoke 2, config the router Eigrp 100, network 193.168.100.0.255. So it would be our good issue lab as well. So it's my bad, I tried, I missed to advertise our interface. That's the reason we wasted our time doing troubleshooting part, but it's worth it. So IP Eigrp neighbor, but we don't have a neighborship, huh? Let's see. So IP Eigrp neighbor, we only have neighborship with the one. So IP Eigrp neighbor. So the router 2 is having neighborship with 100.2 and 100.3, that is spoke 1 and 2. And if you'll go to spoke 2 and 2, so IP Eigrp neighbor, it doesn't have a neighborship. So IP Eigrp neighbor, but it does have. So running config for section Eigrp 133.3. So now we are only having neighborship. So the spoke 2, so the hub is having neighborship with the both both the spokes, but spoke 2 is not able to form the neighborship with the hub, right? Now I want to go back to tunnel and disable split horizon rule. No IP split horizon rule for Eigrp 100. Config D. So IP Eigrp neighbor. So IP Eigrp neighbor. Interface tunnel 10. Shut. No shut. So IP Eigrp neighbor. So now we have a neighborship. Okay. So IP Eigrp neighbor. Okay. We have formed the neighborship now. Okay. Now what we want to see is I want to see hub interfaces, tunnel interfaces in my route. So IP route for Eigrp. I could see the 22 routes that have been learned from spoke 1, right? I am here in spoke 2. I'll show you. In the hub, so IP route Eigrp, I could see all the routes from router 2, 22, 3 and 33, meaning by from both the spokes. And in spoke as well, I could, so IP route Eigrp, I could see dynamically learn routes for hub and spoke 2 and hub, right? Similarly in spoke 2, so IP route Eigrp, I could see, so IP Eigrp neighbor. Okay, so now what we need to make sure IP split horizon rule should be disabled. By default it's enabled. The logic should be at least I could have been seeing the neighborship between hub and spoke and between spoke and hub, and whatever the routes that have been advertised from spoke 1, it won't be carried forward to the advertised back to the spoke 2. That's for that reason. If that's the case, then only split horizon rule should be disabled. But here I just need to, now we have an Eigrp. I'll just tweak, I'm just going to enable split horizon rule in hub again, just to make sure our concept should be right. Interface tunnel 1, tunnel 10. IP split horizon rule for Eigrp 100. I'm enabling this, and it will restart the neighborship. So IP Eigrp neighbor. Spoke 1 is having neighborship with the hub. That is good. Even Spoke 2 should be having neighborship with the hub. So IP Eigrp neighbor. So IP Eigrp neighbor. Right. So we have at least neighborship with the hub. Right. Now the what does split horizon rule says? Any route that have been advertised to the hub won't be advertised back to the other neighbor. So that should be happening. I shouldn't be seeing any of these loopback interfaces. Any of these loopback interfaces uh, in my routing table. So only the routes advertised from a hub like these loopback interfaces should be visible on my routing table. So IP route Eigrp. Now see, only the routes that have been advertised by the hub are being populated on my routing table of spoke 1, not like I didn't see any sort of like routing routes that have been advertised from this spoke 2 in my routing table. Similarly in spoke 2, so IP route Eigrp, I could only see the route that had been advertised by hub, not from spokes, not from spoke 1. So that is what I was trying to explain thoroughly, what the use of IP split horizon command. Like at least we'll be having with like by default when IP split horizon will be enabled, we will be having neighborship only between hub and spoke, right? But we won't be getting any route that have been advertised from spoke to the hub, and hub won't be advertised that route learned from the spoke 1 back to the interface from where it had been learned the route to the other neighbor, right? So that's the one important command that I wanted to explain. I know this this video would be really long, but just to make sure, we are clear on what we are trying to achieve and the command that you are using. So let's configure back our interface channel 10. No IP. Let's disable split horizon rule for Eigrp 100 so that we could see all the routes that have been advertised from spoke to each other. So IP route Eigrp. I could see the routes now that have been populated even in spoke 2. So IP route Eigrp. I could shoot the route that have been advertised from spoke 1 in router 2 in spoke 2, and similarly the spoke 2 routes advertised in spoke 1. So that's the beauty. So IP neighbor, we can even ping 2.2.2.2, right? We can even ping any loopback interfaces of spoke 1, that is 2.2.2.2. Sorry, right? So we have an full reachability, full end-to-end reachability. The spokes are able to exchange the routes with each other, and they are able to communicate with each other. So yes, thank you so much for watching. I hope this video is long, but might be really brainstorming for you as well. Probably you might have found the miss that I have done on the lab during the video, but at least it was quite informative. I think troubleshooting part as well that we have covered so far in this video, and finally we have achieved our goal using phase 1 dynamic mapping with Eigrp. So I'll see you until next time. Try to do the lab, try to replicate it, and try to brush up your skills. Uh, I'll see you on my next video. Thank you.